Hello everyone. This video is created for education purpose only. Myself Meena Labde. I am Assistant Professor in Mathematics, Maharaja Jivajirao Shinde Mahavidyalay, Srigonda District, Ahmednagar. Dear students, we have started SYBSc Mathematics Paper 2nd, Numerical Methods and its Application. We have started our unit number 3, Numerical Differentiation and Integration. So this is our lecture number 4. In previous lecture, we have seen Simpson's one-third rule for numerical integration. In this lecture, we are going to see another rule for numerical integration, and that is Simpson's three-edged rule. So let us first derive Simpson's three-edged rule. Again, as we have derived trapezoidal rule and Simpson's one-third rule from general quadrature formula. We are going to derive this rule, Simpson's three-edged rule, from the general quadrature formula. So in general quadrature formula, if you put n equal to 1, you will get which rule? That is trapezoidal rule. If you put n equal to 2 in the general quadrature formula, you will get what? Simpson's one-third rule. And if you put n equal to 3, you will get Simpson's three-edged rule. So let us see what is Simpson's three-edged rule. So for that, you should know the general quadrature formula for equidistant ordinates. So that formula is I equal to integration a to b y dx. Now initial argument is a, here b is final argument. So if x0 is the initial argument and x0 plus nh, n is number of subintervals and h is interval of differencing. So x0 plus nh will be final argument. So if x0 is your a and x0 plus nh is your b. So integration a to b y dx becomes integration x0 to x0 plus nh y of x dx, and for that the general quadrature formula is h in bracket n y naught plus n square by 2 delta y naught plus n cube by 3 minus n square by 2 delta square y naught upon 2 factorial plus n raised to 4 minus n cube plus n square outside of the bracket delta cube y naught upon 3 factorial. Now in this formula, put n equal to 3. Now if you put n equal to 3 in the LHS, so limit of the integration will becomes from x0 to x0 plus 3h. So interval of integration will be from x0 to x0 plus 3h. And how many functional values in between these? So very first functional value is y naught, then if you put x0 plus h, then you will get value of the function y equal to f of x is y1, then next is y2, and at x0 plus 3h your functional value is y3. So how many functional values are there? Only 4. So as 4 functional values are there, so there are no differences higher than 4. In fact, fourth and higher differences are 0, and therefore neglecting fourth and higher differences from this general quadrature formula. So simultaneously, in fact, we have written this formula up to differences of order 3. So it is not necessary to neglect the term. Just write the formula up to third order forward difference and simultaneously put n equal to 3. So if you put n equal to 3 here, so this becomes 3y naught, then 3 square by 2 is 9 by 2, delta y naught, etc. In this bracket put n equal to 3, this bracket put n equal to 3. So that becomes integration x0 to x0 plus 3h y dx is h outside this one 3y naught plus n by 2 delta y naught plus 27 by 9 by 2, what is that? Then 27 by 3 minus 9 by 2 delta square y naught upon 2 factorial plus putting n equal to 3. So 81 by 4 minus 27 plus 9 by outside of the bracket delta cube y naught. So simplify these brackets and simultaneously put the values of delta y naught, delta square y naught, and delta cube y naught. So what is delta y naught? This forward difference of y naught, and that is पुढचा minus मागचा. So y1 minus y naught. Again delta square y naught we have computed. So delta square y naught is y2 minus 2y1 plus y naught. And how to compute delta cube y naught? It is simply delta square of y1 minus y naught. So it is delta square y1 and it is delta square y naught. So this is delta y naught. So from that what will be the delta square y1? It is y3 minus 3y2 plus y1. So this bracket, collect all these brackets in the next step, but simply you will get this in this term y3 minus 3y2 plus 3y1 minus y0. So in the next step, so collect the coefficients of y0, y1, y2 and y3 together. So you will get 3 by 8 common from all these terms. So 3 and h is already there. So 3h by 8, and in bracket you will get this y0 plus 3y1 plus 3y2 plus y3. So remember this formula and relate it. How many functional values? So y0, y1, y2, y3 between x0 to x0 plus 3h. So at the first and last, write the initial and final argument, and in between argument you have to multiply by 3. So 3h by 8, y0 plus 3y1 plus 3y2 plus y3. So from this you can find the next integration. So next for the next integration, what will be the range of integration? So x0 plus 3h to x0 plus 6h. So x0 plus 3h to x0 plus 6h, y dx is 3h by 8. So again there are four functional value y3, y4, y5 and y6. So y3 and y6 as it is, and you have to multiply y4 and y5 by 3. So that formula becomes 3h by 8 y3 plus 3y4 plus 3y5 plus y6. And from that again you will get x0 plus 6h to x0 plus 9h, y dx is 3h by 8 y6 plus 3y7 plus 3y8 plus y9. And in general you will get, for the general your limit for the integration will be from x0 to n minus 3 outside of the bracket h to x0 plus nh. So how many functional values again? Yn minus 3, yn minus 2, yn minus 1 and yn. So initial and last arguments are as it is. It's not argument, these are the functional values, and in between functional values you have to multiply by 3. So formula becomes 3h by 8 yn minus 3 plus 3yn minus 2 plus 3yn minus 1 plus yn. And in the next step you have to add all these, and what was that previous was this, and add all these integrals. So you will get, so next step is adding all these. So obviously if you add the LHS integral and combine this together, so you will get the integration is x0 to x0 plus nh y dx, and what I just have written whatever RHS in that integral is there. So and in the next step you have to collect these terms together. So integration x0 to x0 plus nh y dx, outside of the bracket 3h by 8 is there, and this one more bracket is there, square bracket is there, and in bracket you will get y0 plus y1 yn plus 3 times y1 plus y2 plus y5 y4 plus y5 plus etc yn. So in this y1 y2 is there, y3 is not there, y4 y5 again y6 is not there, and plus you will get y3 plus y6 plus y9 plus etc yn minus 3. So 2 in bracket yi is where I is multiple of 3, and here 3 multiplied by yj, here j is not a multiple of 3. If j is not a multiple of 3, then what will be the values of j? So j is equal to 1, 2, 4, 5, 7, 8, then 10, 11, etc. So this is the formula for the Simpson's 3-8 rule. But very important thing is that this formula is applicable only when n is multiple of 3, because in the last term you are collecting the yi's which are multiple of 3, and therefore this formula is applicable for n to be the multiple of 3, and this formula is known as Simpson's 3/8 rule. Why 3/8 is there? 3 by 8 is there, and therefore this formula is Simpson's 3/8 rule. And in Simpson's 1/3, so in that formula 1 by 3 was there, and that's why that formula was called Simpson's 1/3 rule. Now this is Simpson's 3/8 rule. So remember this formula, and you have to make your own trick to remember these integration formulae. So let us see example based on Simpson's 3/8 rule. So very first example, evaluate integration 0 to 6 e raised to x dx by Simpson's 3/8 rule using the data. Data is given. E is given. In fact, this is e raised to 0. It's not e raised to 0. It is e raised to 1 is there. So E is 2.71, E square is 7.38, E cube is 20.08, E4 is 54.59, E5 is 148.41, and E6 is 403.42. Also, one more condition, thing is given. Compare the value with the correct value. So first we will compute this integral by Simpson's 3/8 rule, and afterward we will compute the value of this integral by actual calculation, and afterward we will get the error. So let us first compute this integral by using Simpson's 3/8 rule. So here we have not given that we have to divide this interval of integration in how many equal parts. So for you, if you want, you can take any n. So this is n here. So divide the range 0 to 6 into 6 equal parts. One more thing is that it is not mentioned that how many subintervals are there, but you have to decide from the given data. So given data is it is x and respective e raised to x. So how many arguments are there? 1, 2, 3, 4, 5 and 6. So obviously the interval of differencing is just 1 only. So here interval of differencing is given h. So divide the interval of differencing into 6 equal parts. So your h is b minus a upon n. So b is upper limit, a is lower limit, upon n is number of subintervals. So 6 minus 0 upon 6, and your h is 1. Again you call this integral is I equal to integration 0 to 6 e raised to x dx. So take this function e raised to x as y equal to f of x. Now the values of y at each subinterval are given by. Now these values are given. So 0, 1, 2. 0 is lower limit of the integration. So one more value is missing. If you want, you can write, or if it is not given, you have to include that x equal to 0 argument in the given data. So your argument will be from 0, 1, 2, 3, 4, 5, 6, and respective values y is e raised to x. So wherever x is there, put x equal to 0, 1, 2, 3, etc. You will get the respective values of y. So these are your given data. So initial argument, this is your y0, then this is y1, this is y2, then y3, y4, y5, and last is y6. So I have written the given functional values, and Simpson's 1/3 rule. So Simpson's 1/3 rule is x0 to x0 plus nh is missing. So x0 plus nh y dx is 3h by 8. So in bracket initial plus final. So final is this is final and this is initial. So y0 plus y6 plus 3 times in bracket, in which term we have to write. So I should be free from multiple of 3. So in between this is y1, 1 is not multiple of 3, so y1 plus y2, this is multiple of 3. You are not taking this in this term. Then y4 and y5 are there, so I have written 3 y1 y2 y4 y5 plus 2 times then j must be the multiple of 3. So here only y3 is there because y6 is also multiple of 3, but y6 is the final argument, and we have concluded included here y0 plus y6. So here only one term to y3. So whatever y1 y2 y4 y5 y6 are there, just put the values here and simplify. You will get the answer is 406.44, means integration 0 to 6 e raised to x dx is 406.44. So this is the value obtained by applying Simpson's create rule. So let us see what is the actual value of integral. So actual calculation, so 0 to 6 e raised to x. Now integral of e raised to x is e raised to x within the limit x is equal to 0 to x equal to 6. So upper limit is e raised to 6 minus lower limit is 1. So e raised to 6 is given. So this is y6 403.42 is there, minus 1 is, and you will get 402.44. So this is by actual calculation and this is by numerical integration. So what will be the error? So this is exact value and this is approximate value. So error must be the true value minus approximate value. So error is 402.44 minus 404.44, and it must be the absolute value. So absolute value of true value minus approximate value, and that is nothing but 4.02. So this is the error will get in the Simpson's 1/3 rule and by actual calculation. So these examples are very easy, so you can solve at your own. So these are the exercises I have provided for you. So very first is evaluate the integration minus 3 to 3 x raised to 4 dx by Simpson's create rule. So minus 3 to 3. If you want, so if you take h you may take h equal to 1, or if you want you can take h equal to 0.5. So but you have to decide which h is applicable, because here number of subinterval n must be the multiple of 3. So your subinterval will be either n equal to 6 or n equal to 9. So you have to decide which h is applicable, 1 or 0.5. Again same formula is there. So here log to the base e means ln of e in your calculator. So log to the base e is ln e. Again you should decide in how many intervals you have to divide the given limit of integration. But this example you have to do it by all three methods: trapezoidal rule, Simpson's 1/3 rule, and Simpson's 3/8 rule. Here again h is given 0.2, and again this example you have to find the value by your actual calculation method and observe the error, and again you have to decide which approximation is best approximation. So the approximation which gives you the less error will be the best approximation. So you should decide which is the best approximation. It depends on the error. The third example is again 0 to pi by 2 square root of sin x dx, and you have given h equal to pi by 12, means your arguments will be from 0, then next is pi by 12, then next is 2 pi by 12, etc. 2 pi by 12, then 3 pi by 12, etc. up to what? The last argument will be pi by 2. So respective, these are the arguments, and you have to find the values of respective y's. Y is square root of sin x, but here remember you have to compute sin x in the radian mode. So important thing, compute the values of sin x in radian mode only, and you will get answer by trapezoidal rule is this one, by Simpson's 1/3 is this one, and by Simpson's 3/8 is this one. So solve these examples, and we have completed our unit number 3, numerical differentiation and integration. So in this unit, we have seen how to find derivative of a given function from the given data without knowing the definition of function y equal to f of x. Again, here in the next part, we have seen how to compute integration from the given data. So these are the methods of numerical integration: trapezoidal rule, Simpson's 1/3 rule, and Simpson's 3/8 rule. So we have completed our unit number 3. In next unit number 4, we will see how to find solution of first order differential equation by numerical methods. So let us stop here.